All right, here we go. Part two of your notes. And it says to give the domain for the function. And so there's two restrictions that we need to be paying attention to. One, the variables or the variable expressions in the denominator can't equal zero. The variable itself can be equal to zero as long as there's some other stuff going on. For example, if you glance at a right now, x could be zero because zero squared is zero, but zero plus one gives you one in the denominator. So it's okay if the variable itself is, as long as the denominator doesn't equal zero. You need to make sure that whatever value of that variable would make the denominator equal to zero, that is going to be a restriction, something that can't be in the domain. Second, the even index roots, we can't have any negatives in that root. So glancing at C, any x value that's going to make that a negative number inside that radical, which is a square root. So second, a 2 as your index there. No imaginary numbers is really what this is getting at. So let's go through and take a look at it. So for number one, what numbers could x be that would give us a denominator of 0? And those would be our restrictions. And it turns out there's not any real numbers I can plug in for x that will give me 0 in the denominator, because to get 0 in the denominator, I would have to set this equal to 0. So x squared plus 1 equals 0. Subtract 1 from each side, and I have x squared equals negative 1. And I'm only going to end up with imaginary numbers. So x equals negative and positive I. And those aren't real. And so I have as my domain is going to be all real numbers. All real numbers. All right, so that's number or letter A. B, we've got g of x is equal to 1 over the square root of x squared minus 1. And so we got a couple of things we need to consider. First off, what would make the denominator equal to 0? And so if x squared was equal to 1, that would give me a denominator of 0. And so what would give me x squared equals 1? Well, 1 and negative 1. Now, x, what's its relation to those two numbers going to be? Let's go ahead and find out there. So if x is bigger than 1, is that going to produce, be okay for us? So numbers like 2, 3, 4, and those are all going to work out because we'll have 4, or 2 squared would be 4, 4 minus 1 is 3, square root of 3 doesn't give us 0 in the denominator, and it's not a negative number. So any number that x is greater than 1 will work out for us. Now numbers less than 1 but greater than 0, like 0.1 or 0.2, those squared are going to be less than 1. So if we subtract 1, we'll actually get a negative number here in our square root, and that would violate the second restriction, the even index roots that can't have any negatives. So numbers less than 1, that's why they don't work here. Now, as far as and that's going to be true for numbers all the way from 1 to negative 1, but after we get numbers that are even less than negative 1, like negative 3, negative 4, negative 5, when I square them, they become positive, and they'll be larger than 1. So when we subtract, we'll still have a real number. So our domain here is the numbers that are greater than 1 and less than negative 1. All right. C, it's p of x is equal to the square root of negative x. So we don't have to worry about the denominator here, because there's not, well, our denominator is 1, and it's just kind of assumed. It's not even written in here. But we do have to be worried about the second restriction, which is that we can't have any negatives in the in our radical. So x has to be, so our domain is x is less than or equal to 0. If I were to plug in 0, well, negative 0 is just 0, and the square root of 0 is 0, and that's okay. If I plugged any positive numbers in for x, then I would have negative, let's say we plugged in negative 2, it plugged in 2, then we'd end up with the square root of negative 2, which would be an imaginary number, so that's not going to work out for us. But numbers that are, in fact, negative, they'll work out because they'll have a negative of a negative, giving us that positive in the radical. All right, and then you could also write this in another way, that in our interval notation, this is the numbers including 0 all the way to negative infinity. Oops, not negative 8. Negative infinity. Now on interval notation, negative infinity, it isn't an end, so we can't really include it. And this is kind of more just of a technical point, because whatever you have for negative infinity, if you subtract one more, then that's negative infinity. And so it's going to keep on going. So you can never fully include this. So when you have infinity, either negative or positive, it's always the non-inclusive parentheses versus the inclusive ones. That's just something to notice there. And then if we're going to have it in set notation, we've got x is of the set of numbers where x is less than or equal to 0. All right. And lastly, D. All right, for D, our domain is, we don't have to worry about any radicals this time. We're just looking for the numbers that would give us 0 in the denominator. If I had 4 minus x equals 0, then I can see that x would be equal to 4. And I can't have 0 in the denominator, so 4 is outside of our domain. So our domain is all real numbers except for 4. X does not equal 4. All right, hope that helps.